Hello 1020 class, let's do the problems from section 6.1 today. It says for number 1, use the equation of the polynomial function to complete the following. And the function that I'm given is this one, negative 5x cubed minus x. Part A says state the degree and leading coefficient. Well, you should know that the degree is the highest power of x. And the leading coefficient is the coefficient in the leading term. The leading term is the one that has the highest power of x. So this entire thing is the leading term. The leading coefficient is the coefficient of the leading term. So in this case, just negative 5. Describe the end behavior of the graph of the function. Well, the end behavior is, does the curve go up like this or does it go down like that as x goes to plus or minus infinity? And to answer that question, you have to look at the leading term, which is negative 5x cubed. So usually what I do is this. I'll consider what happens to negative 5x cubed as x goes to plus infinity in one case, and as x goes to minus infinity in the other case. All right? So the idea is the leading term, because of the higher power of x, dominates the other terms in size. So whatever it does, whether it goes to plus infinity or minus infinity, will determine what the function f of x does. So just imagine plugging in a huge positive number in for x. Will that make this thing positive or negative? And the answer is it will make it negative, but it will make it a huge negative number. Now, if you plug in a huge negative number for x and then cube it, well, that will stay negative and big. But if you multiply that by negative 5, the two negative signs will cancel out and you'll get a positive number. But it'll be huge in absolute value. So this is the end behavior of the graph. And roughly speaking, this means when we go to the right along the x-axis, the function is going down like this. But when we go to the left along the x-axis, the function goes up to plus infinity, like this. So we don't know what happens in between, but the end behavior is clear just by looking at the leading term. So let me key in my answers, and I will do the rest of the problem in a second. By the way, this is a cubic function because the highest power of x is 3, the degree is 3. Alright, so the last part says support your answer by graphing the function. So we want to use a graphing calculator for this. And I probably will just use the standard viewing window. So I think most of you, all of you, should probably know how to graph by now with your calculator. Alright, so let me show you what my calculator displays in the standard viewing window. It kind of looks like this. Alright. So notice that it is consistent with the end behavior that we talked about in part B. And this one is multiple choice. It looks like the only correct choice is the first one on my example. But let's move on to number 2. Alright, this one says graph the following function. And they give us a viewing window also. This one is supposed to go from negative 8 to plus 8 on the x-axis and from negative 20 to 10 on the y-axis. So let me go ahead and enter that into my calculator, and I'll give you a rough sketch. So my calculator displays something that looks like this, roughly. Alright, part B says how many turning points does the graph have? So let me just quickly give you a rough definition of a turning point. A turning point is a point where the function changes from decreasing to increasing or from increasing to decreasing. But you really want to think of turning points as peaks and valleys. So notice this appears to be a valley, that appears to be a peak, and that appears to be a valley. So this graph has 3 turning points. So when I say a turning point is a point where it changes from decreasing to increasing, you always go from left to right. When you're trying to decide whether a function is increasing or decreasing, this one is going down when you go from left to right. It is decreasing until you get to this first turning point. And then it starts to increase from there to there, and then it decreases from this point to this point, and then at the end it increases. So you can see it changes from decreasing to increasing, then from increasing to decreasing, and then from decreasing to increasing. 3 turning points. But the quick way to decide how many turning points a graph has is just look for peaks and valleys. So I could just make up another quick, easy example. How many turning points does this one have? 1, 2, 3, 4. All right. Now, there is another fact that I want to state here about turning points. And I'm just going to state this without proof. If n is the degree of a polynomial, then the graph has at most n minus 1 turning points. So that doesn't mean it has to have n minus 1. N minus 1 is just the maximum number of them. So that fact you're just going to have to accept without proof. But let's go back to the original polynomial. Notice that the degree of this thing is 4, so that's our n. So the maximum number of turning points this thing could have is 4 minus 1 or 3. So that's how we know we've gotten all the turning points on the screen. So if you're trying to decide what viewing window to use, subtract 1 from n. That'll let you know if you see all the turning points on your screen. So we could not have more than 3 turning points in this case. Well, let's do the next one. It says graph the following function on the window that shows a local min and a local max. And we are given 4 options. It's a multiple choice problem. But here's the function. So if you're watching this video, you might want to practice with me on your calculator. Go ahead and enter that function as y1. Alright, and it looks to me like of all the 4 choices that I've been given, the x-min is always -5 and the x-max is always +5. It's really only the y-min and the y-max that change. So let me plug in a couple of different windows and see which one gives me the best picture. And maybe you can do the same on your calculator. Well, it looks to me that the best picture that I get is the one that has y min of 0 and y max of 30. And the graph of the function kind of looks like this. I'll sketch it for you. On that viewing window, it looks like this. It almost looks like we have a turning point right there and right there. It looks like we have two turning points. By the way, did we get all of the turning points of the function? Yes, we did, because notice that n in this case is 3. So I know that 2 is the maximum number of turning points I can have for this function. So I've gotten both turning points on my graph. Now the next part of the problem says a local max occurs at what point? And let me resketch this thing for you on that viewing window. Alright, now notice that this one appears to be the location of the local maximum, because the local max is a peak, the local min is a valley. So the other point, the second point, is where a local min occurs. But let's find this point first. And I know on the TI-84, you have to go to calculate above the trace key, and then choose maximum. Press enter. It'll take you back to the home screen. When it says left bound question mark, move the cursor clearly to the left of this first point and press enter. And then when it says right bound, move it clearly to the right of that point and press enter twice. And it should give you the coordinates of that local maximum point. And my calculator says that point is this. Alright, and it does say round to the nearest hundredth, so I guess we'd probably want to write that as negative 1.33 and 9.19. And I probably will post a video showing how to find the local max and min of a function in the Moodle class. But let's find the second point too, and I'm talking about this guy right here. So do the same thing. I know on the TI-84 I've got to go to the calculate option, which is right above the trace key. This time choose option 3, which is minimum. And let me resketch the function. It kind of looks like this. So here is the minimum point. First move the cursor clearly to the left of it and then press enter. Not too far to the left, but just a little bit to the left of it. And then when it says right bound, move it clearly to the right of that point and press enter twice. And my calculator gives me 0.8 for that point. It actually gives me something that looks like this. I'll show you. It actually gives me this. But whenever you see this E-7 thing, that really means times 10 to the negative 7. So that first number is really 0.00000001148. So that's just a rounding error of the calculator. It's essentially just 0.8. So if you see something like E-10, just make it a 0. So your calculator actually does allow you to find those max and min points, those turning points. But let's do the last one, and I will post a video or two for you showing you how to do that on each calculator. Use technology to find a local max and two local mins of the graph of the following function. we've got x to the fourth plus 4x cubed plus 4x squared. So they don't give us the window to use, and we're also not given multiple choice. So we kind of have to figure this out on our own. So let me enter it into my calculator. And I might start off with a standard viewing window just to see how it looks. By the way, notice that the maximum number of turning points is 3. And you know, I just tried the standard viewing window. I think I got a pretty good picture just from that, because I get this picture, roughly. And notice that I have all 3 turning points. There's one right there, and one right there. So I don't really need to use a different viewing window. I might just zoom into this part a little bit so I can see it better. And you can do that if you press zoom and then zoom in. And it'll zoom in to wherever the cursor is. That might make it a little bit easier to find the maxes and mins. But it looks to me like there are 2 points where we have a local minimum, and we have 1 point where we have a local maximum. And the first part of the problem says, where is the local maximum? Alright, and they want an ordered pair, so we've got to start off with this point. So once again, on this calculator, I go to Calculate Maximum. I guess if you're doing the Inspired, you go to Menu, Analyze Graph, and then Maximum. But let me tell you what I get. It looks like negative 1, 1 is that first maximum point. But we do have 2 minimum points. So let's find this one first, the one on the left. So on both calculators, after you select minimum, you move the cursor a little bit to the left of the points that you're looking for, or in the case of the Inspire, move that vertical line a little bit to the left of the point that you're looking for. And then press enter, or select. And then when it says right bound, move it a little bit to the right of it. And I get negative 2, 0 for this thing. And let's try this last point. That is also a minimum point. Okay, so once again, I'm going to get a 0 in there. It looks like 0, 0 is the answer, and I'll show you what the calculator actually gave me. It gave me this one for the x-coordinate. So notice that E thing again. And for the y-coordinate, it gave me this. But again, that's just a rounding error of the calculator. Both of these numbers are essentially 0. So 0, 0 is the second point.